Morning, seventh grade. Happy Friday. Today we're doing lesson 5 in unit 3. Our lesson today is on factoring algebraic expressions. We've been doing distributing for the past 2 lessons. Factoring is actually the inverse of distributing, the opposite. So whereas distributing, we're putting a number into an expression, in factoring, we're taking a number out of an expression. And distributing involves multiplying, so factoring is going to involve dividing. And we'll see this in the notes in a second. We're going to jump right into it. Please make sure after we finish the notes and the I do's, you guys getting straight to the we do's. And then hopefully you'll have time to finish IP in class. Like I know Anaya and Angelina and Julissa did yesterday. Really awesome job, guys, again. Please make sure you guys all get into that. And otherwise, I'll talk to you guys in a little bit and have a great rest of your day. Here is the notes, because that sounded like an outro and it was not. Sorry. I also noticed yesterday I did not put it in expanded screen. I think it should be, so you guys can all see. All right, cool. Our title today is simply factoring algebraic expressions. Again, that is U3, L5. This is 7th grade math, and today is November 6th, 2020. So before we can really get into factoring algebraic expressions, we have to talk about finding the greatest common factor, GCF, which you should have learned in both, I think, 5th and 6th grade. But it's important that we go over it now and that you have a resource to look back at it for your notebook. So our first subheading today is going to be finding the greatest common factor, or commonly known as GCF. Subheadings are always a little squiggly line, although a little off. Oh well. So the way that we find GCF is we find GCF by first listing all of the common factors listing all the factors. I should not say common there. I apologize. Listing all the factors of the given terms common is what we're looking for, but we want to start with the factors first. Sorry, restarting. Find GCF by listing all the factors of the given terms, and then finding the largest and greatest are 2 words for each other. I'll use largest because I think it's easier for us to conceive of. The largest factor they have in common. Now, a lot of times we'll see this and we'll work with this with expressions that only have 2 terms. But the reason why I didn't say 2 terms here in given terms is because you can really have as many terms as you want in there. If they all have a common factor, you can factor it all out. So just simply saying GCF is the largest factor that 2 or more, again, we can have more than 2 terms, can be divided by. And the reason why I put like this is because I think it helps us ask the question of ourselves, right? How do I find this? I saw this, so we find it by finding what they can both be divided by. But for example, of finding GCF, we're going to try and find the GCF of 24 and 16. Put what it equals over here. Well, I know that 24, that could be 1 times 24. Next one up could be 2 times 12. Next one up could be 3 times 8. Next one up could be 4 times 6. Up, and 5 doesn't go into it. And then we're already at 6, so that's all the factors. Let's take 16. 16, it could be 1 and 16. Next one up could be 2 and 8. Next one up, 16 can't be divided by 3. Oh, I almost went off the page. I apologize for that. But notice, 16 can't be divided by 3, so I can't do 3. So go up again. Next one is 4. 16 divided by 4, but that's just 4 times 4. So I don't need to put it twice. I only need to put it once. And 16 can't be divided by 5. It can't be divided by 6. Can't be divided by 7. This is all the factors as well. There's a couple of factors they have in common. They both have 1s, they both have 2s, they both have 8s, and they both have 4s. So again, we're looking for the largest one. That's going to be 8. And it's really helpful. Just circle it on both lists. GCF for 24 and 16 is 8. So you can factor 8 out if you had 24 and 16 as your terms. And we're going to practice this in 1 second. Our next little subheading. Yes. All right, our next little subheading is factoring expressions. I know this is kind of the overall heading as well, but you need to know this concept of GCF before you can really factor expressions. And again, remember what I said at the beginning. Factoring is the inverse of distributing. And we can see that if we do the same expression kind of both ways. So if I was expanding an expression, remember, we expand expressions by distributing. This is another way of saying distributing. Expanding an expression versus factoring an expression. Again, we're going to be comparing the two here. So expanding an expression, I can start with something like 2 times, in parentheses, x plus 4y, close parentheses. Remember, anytime we distribute, step 1, draw your arrows. Step 2, write the multiplication out. 2 times x plus 2 times 4y. Step 3, write your final answer. 2x plus 8y. All right, so we know that 2x plus 4y, 2 times the sum of x and 4y is the same as 2x plus 8y. That's great. What if I had to go back the other way? If I had to start with 2x plus 8y, how would I be able to find and put it back into this form? Because that's what we're really asking anytime we want you to factor. So let's start with 2x plus 8y. Remember, one of the best ways to find GCF, like we did right here, listing the factors out. So let's list these factors out. For 2x and for 8y. For 2x, you can always start with 1 times the number, so times 2x. Go up from 1, 2. Well, 2 times what equals 2x? 2 times x equals 2x. So I have 2, and I have x. And there's no number larger than that, so no greater GCF. 8y, again, start with 1 and 8y. Can be divided by 2. 2 times 4y. Can't be divided by 3. Oh, it can be divided by 4. 4 times 2y, not 5, not 6, not 7. Oh, look, it can be divided by 8. 8 times y. So again, we're looking for what, this is one way to think about it, is listing out these factors. I'm going to tell you another way to think about it in a second. But first of all, when we list out these factors, we're looking for the largest one. They both share 1. X's and Y's aren't common factors, so they can't share that. But they also both share 2. And that is going to be GCF. So I'm going to take 2 out of this. Remember, we're distributing, we're multiplying. So here we're dividing. The way to find out what should be inside parentheses is by dividing what we're given, 2x plus 8y, by the common factor, by 2. Oh. All right, so 2x plus 8y divided by 2. Kind of similarly to distributing how this goes to both numbers, this division can go to both numbers. So we have 2x divided by 2 plus 8y divided by 2, which would leave me with x plus 4y. So that's what's inside parentheses. That's what's outside parentheses. That tells me that 2x plus 8y is the same as 2 times x plus 4y, which again is what we started with over here. That should make sense. They're not inverses, they do the exact opposite. Now, I do think this is a bit of a time-consuming process, and I don't want you doing it every time because there's a slightly easier way to think about this. Most of the time, we're pretty good about identifying GCF if you know your timetables well. We're in 7th grade. I think almost all of you, if not all of you, know your timetables really well. What that means then is that you should always be asking yourself the same question when you're distributing. Sorry, I didn't mean to, what was that? Oh, sorry, distributing, Jesus. When factoring, you should always ask yourself the same question when factoring. When factoring an expression, and we're going to write this as a note as well, so we can always go back to it. When factoring an expression, comma, always ask yourself what is the largest number that these terms can all be divided by. So if I'm looking at this one, I'm asking myself that, what's the largest thing that 2x and 8y can both be divided by? Well, it has to be 2. Because I know 2 and 8 can both be divided by 2. X and y don't have anything in common. It has to be 2. Most of the time, you can do that really quickly. And then you know, okay, you start with the 2 out here, right? Put 2, open the parentheses. All right, what's 2x divided by 2? I'm just going to go with x, first number. Plus, you should keep this same operation. Okay, then I need to do 8y divided by 2. What's 8y divided by 2? That's just 4y divided by 2 is 4y. So that's another quick way to do it. Okay, this is the really formalized way, but I didn't want to make you guys take a page of an extra page of notes for something that is silly, that is quick. But we'll practice that process today, and we'll practice it starting by looking at our IDs. Remember, if I went too fast, or well, first of all, if you have any questions, always don't hesitate to ask when I'm with you guys, or during just text me whenever. I'll be happy to help whenever. But remember, you can also always pause and stop the video so that you can catch up and take notes. Now, we are going to go to IDs. And I am going to, I want to do both ways. I don't want to do both ways because I think, again, that one way is really time consuming. And this shouldn't be as time consuming as that method is. So I'm going to talk through how I think through this. We'll see if we start having trouble with it, we'll need to go back to the other method because it makes it very clear what each of the answers is. But I think we'll be able to handle this. I think you guys are way more than smart enough. So again, we're asking ourselves every time we're trying to factor, what is the largest thing that both numbers can be divided by? A and B can't be divided. So look at the coefficients, 3 and 6. Well, 3 and 6 are both on the 3's times table. So they can be divided by 3. So I'm starting with 3 outside parentheses. Inside parentheses, that's what, okay, what is 3a divided by 3? Well, 3a divided by 3, just be a. So I have a. You could put 1a, be the same thing, just a. What's 6b divided by 3? Well, 6 divided by 3 is 2, so we get 2b. plus, always keep the same operation, 2b. And that's it. That's the answer. Like, factoring is not that difficult if you know your times tables and you follow the same process and ask yourself this question. You have to be careful. Sometimes we factor something out and we don't realize there's another number that can still be factored out. But you can always check that by going back and saying, okay, in parentheses, I have a plus 2b. Is there anything they can both be divided by? Nope, they're not, so I'm done. I'm good. Again, with something easy like this, you don't always need to do that, but we'll get harder and harder, and we will have to ask ourselves that question. We always want to check ourselves. All right, item number 2. It's similar, but here instead of 2 variables, I have a variable and a constant, 3z minus 30. Again, ask yourself, what can they both be divided by? Well, 3. Again, just like we had 3 up here, 3 and 30 are both on the 3's times table, and 3 can't really be divided by much else. 3 can't be divided by much else. It has to be 3. So again, I'm going to start with 3 outside parentheses. 3z divided by 3 is just z, 5z, or 1z. Remember, you drop down the same operation. We've been having plus. Don't forget to bring down a minus this time. And you can't forget that minus. Now, 30 divided by 3, that's just going to be 10. 3 times z minus 10. Check. Can z and 10 be divided by the same number? Nope, they can't. So all set there. You can also check whether you divided correctly by then distributing it in. Check. By 3 times z minus 10, distribute 3z minus 3 times 10 is 3z minus 30, and that checks out. You can always do a quick check like that just to make sure that you did it correctly. But otherwise, it's not too complicated here. Good luck with the redos. I'll see you guys in a little bit. Hope I'll be able to go over those with you during class, not during specials. That would be nice. I think next week we might do something different than live stream, but we're going to see. I really want to work directly with you guys. I'm sure it's a little boring watching the videos all the time. I'm probably still going to make them and put them up, but we'll be doing it live, I think. Fingers crossed. We'll see. Otherwise, though, guys, get to the videos. Try and finish IP in class so you don't have to do it over the weekend. Make sure you're uploading the notes. Still missing a lot of notes. On those are going to be due on Monday. And tomorrow we're going to just be sending a quick message home about your performance for the week with homework and notes. But it's a half day. You guys are going to have a great weekend. Go enjoy the rest of your day, guys. Talk to you guys in a little bit. Bye, everyone. I need to stop sharing first. Bye, everyone.